capacitor is connected to a 27 millihenry inductor, what's the angular frequency of free oscillations of the circuit? It's a question on LC oscillations. We have an inductor and a capacitor, and for free oscillations, that means there is no energy loss, we have omega is 1 by root of LC. This happens to be the same expression as in resonant frequency of an LCR circuit, but these two are not related. Putting the values, we get 1.11 into 10 to the power 3 radian per second. Question number 7.8. Suppose the initial charge on the capacitor in exercise 7.7 is 6 millicoulomb. What is the total energy stored in the circuit initially? What is the total energy at later time? In exercise 7.7, we had an inductor and a capacitor, and here it's saying the initial charge on the capacitor is 6 microcoulomb. So Q is 6 microcoulomb. The energy in the capacitor is Q squared by 2C, which is 6 into 10 to the power minus 3 whole squared divided by 2 into C is 30 microfarad, so this is 30 into 10 to the power minus 6, which comes to be 0.6 joules. This charge Q is the maximum charge on the capacitor, because as time passes, this charge Q goes on decreasing. So when this Q is Q max, this energy is the maximum energy. As time passes, this energy gets converted into the energy in the inductor, but the total energy remains constant as there is no loss of energy. So the total energy at later time remains the same, that is 0.6 joules.